to learn. All right. Math 3 classwork 7.6. Here we go. Sine. Does sine represent the x or the y coordinates of points on the unit circle? That is a question. Is sine the x or the y coordinate? Good. That means that sine is positive anywhere that y is positive, and sine is negative anywhere that y is negative. Now, if you look at the circle I have here, right here, if you look at this circle and you look at the quadrants and you know that this is the origin right here, which of these quadrants have a positive y value? Which quadrants have a positive y value? I'm waiting for someone to respond, but quadrants 1 and 2. Yes, thank you. Which quadrants have negative y values? Thank you. 3 and 4. You got it. Now, if I reciprocate a positive number, for example, let's say I throw at you the number 1/3. What is the reciprocal of 1/3? 3. A positive 1/3 has a reciprocal of positive 3. What if I give you negative 3/4? What is the reciprocal of negative 3/4? The reciprocal is negative 4/3. So if I reciprocate a positive number, I get a positive number. If I reciprocate a negative number, I get a negative number. That means that the reciprocal of sine, which function is the reciprocal of sine? Which trig function is sine's reciprocal? Good. Cosecant theta. So the reciprocal of sine theta, which is cosecant theta, it is always positive. And let me remember what I actually wrote here. Oh, it's always the same sign as sine theta. But you don't have to write it quite that way. Sine and cosecant are both positive in quadrants 1 and 2, and they are both negative in quadrants 3 and 4. Now, next, cosine. Does cosine represent the x coordinates on the unit circle or the y coordinates? X, very good. That means cosine is going to be positive where x is positive, and cosine is going to be negative where x is negative. Let's go over to the circle right here. Which quadrants have a positive x value? Quadrant 1 is positive for x, and which quadrant is also positive for x? Good. Quadrant 4. X is negative on the left side. Who is the reciprocal of cosine? Which trig function is cosine's reciprocal? Good. Secant. And secant theta is always the same sign as cosine theta. So that means cosine theta and secant theta are positive in quadrants 1 and 4. Cosine theta and secant theta are negative in quadrants 2 and 3. And then one more pair, tangent. And who is the reciprocal of tangent? And I'm hoping you are trying to type cotangent. Now, there are two ways you can look at tangent. If you look at it as sine divided by cosine, then you can say that tangent is positive where sine and cosine are both positive or both negative. But I think it's actually easier if you think of tangent as slope. So any line that is drawn through the origin any line through the origin that has a positive slope. And I'm going to draw a line. And even though it doesn't work as well as I would like it to on this document, I just want to show you this is a line through the origin. This heads downhill from left to right. It is a negative slope. I want to be able to just turn this, but I want it to turn where it's anchored at 0, and I'm not sure how to do that in this venue. Here's a line with a positive slope that goes through the origin, heading up from left to right. Which quadrants are the quadrants where slope is positive? Right, 1 and 3. So positive slopes 1 and 3, negative slopes are in the other two. And in the typed up answers, I have it written as tangent is positive where sine and cosine are the same sign, and negative where sine and cosine are opposite signs. But if you see it faster based on where there is positive slope versus negative slope for a line through the origin, you might see that faster. So tangent and cotangent are positive in quadrants 1 and 3. They are negative in quadrants 2 and 4. And that is all that I needed to say about the positive and negative values of the 6 trig functions. Now, we're going to start bringing everything together. For these first couple of problems, you are going to use the given information to find the exact value, not a calculator value, the exact value of the remaining trig ratios. So, some people are taught to find these using reference triangles within a unit circle. And that's a completely legitimate way to do it. I have found, and I've seen YouTube videos to tell me that other people have also found that that is kind of a tiresome way to go about it. And there are better ways where you don't have to remember how to make your reference triangle. What you need to know is who's positive and negative in which quadrants. So I want you to see that you are given a value of sine that is positive. This statement is telling you a couple of things, but one of the things it's telling you is that you have a positive value for sine. Sine represents y. Which quadrants have positive y values? So with just that one statement, I know that my angle theta is in either quadrant 1 or quadrant 2. And actually, there are two terminal sides of angles that will land in each quadrant, one in one quadrant, the other in the other quadrant, who have that value for sine. So right now, with only that piece of information, there are two possible angles. But when I bring in an additional piece of information, one of them is the right quadrant. So of the two quadrants that we could be working with, which of those two quadrants has a negative tangent value? And there you go. Yep, you're already telling me there. Quadrant 2 has a negative tangent. And one way you could look at it also is tangent is negative in quadrants 2 and 4. And then you're looking for which quadrant has both of these. And I want you to know that if you do continue on the train that heads toward calculus and physics, that you're going to want to understand trig functions, and you will get better at it, where what I'm telling you right now actually comes really, really quickly. So here we go. We know that we are going to be working in this particular quadrant. In that quadrant, I know who's positive and who's negative. You're asked to find the exact value of the remaining trig ratios. You're given one trig ratio, there are 5 others. So I'm going to start listing the other 5. The other 5 are cosine theta, tangent theta, then there's, let's see, we've got a cotangent theta, we've got secant theta, we've got cosecant theta. If you know what quadrant you are in, you know who's positive and who's negative. And by the way, I should also point out to you that you can write the following out. Let me show you. I'm just going to the side list, I've got sine, cosine, tangent, and then cosecant, secant, and cotangent. Sine is equal to the y values. Cosine is equal to the x values. Tangent is equal to y divided by x. I have the reciprocals sitting right across from them. So cosecant is 1 over y. Secant is 1 over x. And cotangent is x over y. So if you understand which quadrants have positive and negative x values, and you understand these relationships, you don't need to memorize who's positive in which quadrant. There are memorization techniques that are out there, and you know, they're great if you're just trying to pass a test, but if you need to actually remember your trig and use it in later classes, you might remember it through some memorization technique, but I think it's better to see how you know what it is through the logical creation of the trig functions. So here we go. What have I been going on and on about for this? In quadrant 2, this is a place where y is positive and x is negative. Understanding that, I know the signs of all my trig functions. Cosine has a negative x value over there. Tangent is showing a negative slope in that region. Cotangent is going to do the same thing as, it's just going to be tangent's reciprocal, so it keeps the same sign. Secant is the reciprocal of cosine, 1 over x. X is negative in that quadrant. Cosecant is the reciprocal of sine. Sine represents y. Cosecant represents 1 over y. Y is positive in that quadrant, so cosecant is positive. So for myself, I like to first figure out who's positive, who's negative, and then move on to the specific numbers. But you could do the signs last. It doesn't matter what order you do these things in, but your final answer needs to be correct. So now what you're going to do next is you're going to draw a right triangle in any way that you want to draw a right triangle. Everybody draw a right triangle. Draw your own right triangle. Orient it how you like to orient it. What makes the most sense to you to draw a right triangle. And let me see, does this one have right triangles? It does not have right triangles specifically. But I could draw a triangle. Oh, no, it won't let me do a right triangle at all. It's only letting me do isosceles. Well, that's just ridiculous. Okay. I'm going to draw a right triangle, and I don't have to orient it the same way that you orient it. Pick one of the acute angles to be theta. Which one to you in your oriented triangle makes sense to put a theta so that you know which side is opposite, you know which side is adjacent. Now, we have over here that the sine of theta is equal to 2 divided by 5. We also remember from right triangle trig that sine is equal to opposite over hypotenuse. That means for the side opposite the angle, you can say that the length of that side is 2. The hypotenuse is always opposite the 90-degree angle, and you can say that that hypotenuse is length 5. That means you're creating a triangle for which the sine ratio is 2/5. You might have your triangle oriented differently, but once you have a leg and the hypotenuse of a right triangle, you have a very specific right triangle. Now, Pythagorean theorem your way to the third side. Find the length of this leg with Pythagorean theorem. Let's see. I'm just going to say that's letter A. And a squared plus 2 squared equals 5 squared. So a squared plus 4 equals 25, which means a squared is equal to 21, which means a is the square root of 21. And now the next thing you're going to do is take this triangle and you know the right triangle ratios of all of your trig functions. You are now ready to write them down. Cosine is what over what? And I'm assuming you are about to write adjacent over hypotenuse. If cosine is adjacent over hypotenuse, then look at which side is adjacent. That's the root 21 divided by the hypotenuse, which is 5. You now have the cosine ratio that matches the right triangle that you use with the sine ratio of 2/5, and it is located in the proper quadrant. Tangent, what is the side ratio for tangent? SOHCAHTOA. Tangent is TOA, opposite over adjacent. So here's theta, opposite side is 2, adjacent side is root 21. Now the only three I have left are reciprocals of ones I already have. So when you do these problems, you can actually just find 3 trig functions, sine, cosine, and tangent, and reciprocate them for everyone else. Cotangent is tangent's reciprocal. Secant is cosine's reciprocal. And cosecant is sine's reciprocal, which is what we started with. And now you have the exact value of the remaining trig functions based on that information. Now, I realize you're never going to use trig in this manner. Yeah. Whoa, hold on. Once I finish practice test part B, may I leave? Just sit still and let me finish going over this, because you might learn something that you didn't put together yet. Okay. So what I was saying was, I know that this is not the way you're going to actually do trig when you have a trig problem in the future. But what these problems are doing are trying to get you more acquainted with the trig functions. It's like when you have a new friend, you have to have boring conversations to a certain extent to get to know who they are. What's your favorite color? What's your favorite band? You know, you've got to ask all those boring questions that your good friends, you already know the answers to. You don't have to bother with those boring conversations. Then again, maybe some of you don't think they are boring conversations. But to get acquainted with trig functions, you kind of have to do some things that, you know, you wouldn't do in every day with a function that you understood. You would just be ready to use it. Not that you use your friends, but yeah. Hopefully you get the point of this is trying to help you learn more about what the trig functions are about and their relationships with each other, so that in the future, if you have to deal with trig, you know it well enough to work with whatever situation is in front of you. All right, here we go. I like to do my quadrants first, but that doesn't have to be the way you do it. Now we are supposed to come up with the remaining trig ratios. So what I'm going to do is I'm going to write down that I need to find sine theta, cosine theta, and tangent theta. And I'm going to put across from them their reciprocal functions, because that makes it easier for me to write a bunch of information down. Sine's reciprocal is cosecant. Cosine's reciprocal is actually the function we know. Tangent's reciprocal is cotangent. And, you know, speaking of, secant is cosine's reciprocal. All you have to do is go, hey, Secant, I know what you are. Reciprocal, and I have cosine. So reciprocating keeps the sign that it is, and then I flip the fraction. I already know one. I only have 4 more to go. And I want to take a look at the positive negative issue and make sure that I have the right values. So I have a negative secant. Secant is the reciprocal of cosine. Cosine is x. So really what I want to know is, where is x negative? X is negative in which quadrants? Two and 3. Now, the other piece of information is that you're dealing with a positive value of sine. Sine is represented by the y coordinates. So it's positive where y is positive. Since secant is just the reciprocal of cosine, can't you just go and find where cosine is equal to 0? I'm not sure what you're referring to that is on what we're doing right now. But right now we aren't dealing with cosine being, negative. Yes. Yes. When you're dealing with, if you know secant is negative, then you know cosine is also negative, and you can just go with it on that. And I will tell you, every time that I do have to work with either secant or cosecant or cotangent, I always work with them by reciprocating them first, so that I only really have to work with 3 trig functions. And then once I know the reciprocals and have done it long enough, if I do have to deal with it on its own, I can figure out how to work with it by understanding who it's the reciprocal of. And that saves half your trig right there. All right, so where is y positive? Y is positive in quadrants 1 and 2. And we want to look at which quadrant has both secant being negative and sine being positive, or x negative and y positive. So we've got quadrant 2 again. Now this is going to allow me to begin answering. Let me write that down. Okay. If I am in this quadrant right here, quadrant 2, and sine represents y, y is positive. And the reciprocal of y is also positive. In quadrant 2, if I draw lines through the origin and they go into quadrant 2, they are lines with negative slopes. So that means tangent is negative and its reciprocal is negative. Now, I don't have to worry about where to put a reference triangle, which is what these problems will usually ask you to do. I just need to draw any triangle oriented any way that I so choose. As long as I know my SOHCAHTOA trig ratios, I can make this triangle. Now, in this case, I'm dealing with secant theta being negative 7/4. What I'm going to do is I'm going to absolute value my trig answer, because I have already dealt with the issue of it's negative, and I set that aside. And it's nice to not have to worry about is it positive or negative, and just say I've got a ratio of a 7 to a 4. Secant is cosine's reciprocal. So if you like, you can look at cosine's reciprocal of 4/7. And again, I want to say cosine, yes, it is a negative number. But once you know what quadrant you're in, you can ignore positive, negative, and just focus on the ratios. Then I want to remember that cosine is the ratio of the adjacent side over the hypotenuse. The hypotenuse is always the longest side across from 90. I'm going to put a 7 on that. Then of the two legs, the one that's adjacent is the one that is helping to create the angle with the hypotenuse. I'm going to put a 4 on that. Once I have two sides of a right triangle, Pythagorean theorem will give me that third side. So I'm going to write down that this side is length B, and I've got now leg squared plus leg squared equals hypotenuse squared. So 16 plus B squared is 49, and then 49 minus 16 gives me 33, if I can subtract today. And then I have the square root of 33. And again, I don't have to worry about positives or negatives because technically when you take a square root, you throw out a positive or negative. So that's why I like just having them separate. I got my positive negative issue on one side, and then I separately just take care of the numbers themselves, the ratios. And now we can answer all the questions because we know that sine is the ratio of opposite over hypotenuse. So then I write down that the answer is opposite is the square root of 33 over the hypotenuse, which is 7. Sine's reciprocal cosecant, I'm just going to reciprocate and write it. Tangent is opposite over adjacent. Cotangent is its reciprocal. And I'm done. So the answer to this problem is just that piece of information that I just boxed in red. Now, we need to go over some more problems, a different type of situation. And I'm going to actually start with the hardest one in case we run out of time. This hardest one, you can always do the easier problems in the same way you're doing this hardest problem, but there are some easier ways to do the other problems than what I'm going to show you here. So here we go. Here we go. Are you ready? Inverse cosine. The answer to an inverse cosine is an angle. I need to know the quadrants that inverse cosine uses. Do you remember that inverse cosine only gives me angles from 0 to pi? We learned that yesterday. So I'm only going to look at quadrants 1 and 2. And what you want to remember again is, well, actually, let me write this. If I do the forward cosine function, I put an angle in it, and I get out a number. If I'm on a unit circle with a radius of 1, I'm going to put parentheses, radius is 1, then that's just flat out x. That means when you write inverse cosine, the input is the x coordinate on a unit circle. That means you have an x coordinate of 5 over 8. Now, x coordinate wise, you've got 0, 1, -1. This isn't one of the unit circle x values that you're expected to know, but you do know that that's a positive number. And a positive number of 5/8 is somewhere between 0 and 1. What this allows you to know is you know you're dealing with quadrant 1. when you have an inverse trig function with a positive or negative number going into it, you know which quadrant you are in by putting together the quadrants that inverse function uses and whether you're dealing with positive or negative for the input. So if I'm sitting in here, then I'm dealing with every trig function comes up positive when I am in quadrant 1. Now here's what I want you to think about. I replaced inverse cosine of 5/8 with a theta because the answer to an inverse trig function is an angle. This expression is actually asking me, what is the tangent of that angle? I want to know what is tangent. And what you can do is create a right triangle like we did in the previous problems. Pick theta to be whatever angle of the two acute angles. And then realize that the statement of inverse cosine of 5/8, this expression is equal to an angle, an acute angle that I am putting in a triangle right there. This means the cosine of that angle is 5/8. Because remember, inverse functions swap their input-output. And then I remember that cosine is adjacent over hypotenuse. So then I come over here on my right triangle. I have my adjacent side. I'm going to put a 5 on it. My hypotenuse, I'm going to put an 8 on it. And I can Pythagorean theorem my way to my third side. Yes.
If cos is the inverse of cos to the negative 1 and it's 5/8, wouldn't the 5/8 switch be 8 over 5?
And this is why I am angry at some very old people who died a long time ago. If I go back over here to yesterday's classwork, I warned you, I spent a while warning you about this issue. It confuses people like nothing. I can't even express how much it confuses people and how long it confuses them for. You see -1 and you think reciprocal because when -1 is in an exponent, that means reciprocal. But unfortunately, somebody chose to use that as the symbol for inverse, and inverse and reciprocal are only the same thing. If you're dealing with multiplication and division, the operations. So this messes people up to no end. What you want to realize is that -1 sitting in a superscript where you would put an exponent is not an exponent. Uno reverse card. Okay. Yeah, maybe. So this is actually a completely different function than reciprocal, and it is really easy to mix those up until you have just made mistakes so many times that you've finally gotten it straight, if that makes sense. Unfortunately, people have to go through several mistakes before it really sinks in that this is a notation issue of not reading this as exponent -1, but reading it as a symbol that means an inverse function where x and y swap. And it's great because reciprocal and swapping seems pretty much the same thing, but it's not. It's swapping stuff. Oh. And that's why I went right back over to, let me tell you, I'm going to have to say this so many times to any one class. The longer a time period I have to teach trig, the um, the more times I have to say this. But if you want to finish learning the lesson, stay. I'm going to keep teaching this lesson for the next 10 minutes. So stay. However, I can't make you, but you should. So watch the video if you are leaving. Now, I need to use Pythagorean theorem to get this third side b. So I have legs squared plus legs squared equals hypotenuse squared. That means I have 25 plus b squared equals 64, which means that 64 minus 25 is 39. So I have the square root of 39 is b. Now, this expression was asking for the tangent of the angle. The tangent of that angle is the ratio opposite over adjacent. And when I look at what that gives me, that means the expression is equal to the square root of 39 divided by 5. That is the answer to this expression. Now, that was the hardest problem. I need to tell you that you can do the others a little bit faster because the other ones are either unit circle trig or something super special. Number 3 is something super special. Inverse cosine uses the top half of the unit circle from angle 0 to angle pi. When I look at the inverse cosine of 2/5 by itself, the answer to that inverse cosine is an angle. Now, if I rewrite this in the forward function, then I change my input to being the theta and my output to being the 2/5. Cosine is an x-coordinate, and this is a positive x-coordinate. So I'm going to say positive 2/5 is about right here. That takes me to a certain angle. And now I'm finding the cosine of that angle. But wait a minute, I just did inverse cosine. Oh no, hey, oh my goodness. That's an inverse inside the original function. But I'm going to warn you that there are times if that number had been negative, I would have had an issue. I'm not throwing you that issue in this class. In this class, you're not going to worry about that. You're going to look at this and go, oh my goodness, wait a minute. Inverse cosine inside forward cosine, what does that mean? This expression is flat out just the 2/5. I want you to know they cancel each other out. I want you to know that there are some exceptions to this rule, but they are based on the issues of the angles that an inverse function is allowed to use. We're not going to get into that in this class, but I want you to just be aware of that. Now, the other ones are not exact inverses, but these are going to be quick. So here I go. Inverse tangent uses the right half of a unit circle from 0 to pi over 2, and then backward from 0 to negative pi over 2. Root 3. So the inverse tangent of root 3 is equal to an angle. the forward tangent of that angle is root 3. So it's asking what angle gives me a slope of root 3. That's the steeper positive slope of my 3 possible unit circle slopes that I need to be aware of. And that takes me to an angle, but I don't need to know that angle. I need to know the sine of that angle. The sine is the y-coordinate of that point on the unit circle, and the points on the unit circle for y-coordinates are 1 over 2, root 2 over 2, and root 3 over 2. So this expression turns into the y-coordinate root 3 over 2. Now, you could, again, go through the process that I did over here with number 6, but I think it's faster if you have some unit circle to work with. All right, this one is going to be very important to take a quick look at because we're dealing with a negative number going into tangent. I am saying that the inverse tangent of negative root 3 is equal to an angle. That means the forward tangent of that angle is equal to negative root 3. I'm going to draw the right half of the unit circle because inverse tangent only uses the right half from 0 to pi over 2, and then from 0 backward to negative pi over 2. A negative root 3 slope is the steepest slope in the negative slope arena. There are 2 other slopes that you're expected to know on the unit circle. That takes me to a particular angle, but I don't need to know the angle. I just need to know the sine of that angle. So the sine is the y-coordinate. And what is the y-coordinate of that position on the unit circle? My 3 negative y-coordinates for quadrant 4 are negative 1 over 2, negative root 2 over 2, and negative root 3 over 2. Ding, 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 ding. That is the answer to that expression. So there you go. And 3-day weekend. Woo-hoo! Make sure you study and understand this the best you can.